And let's get into it with one of our favorite interstellar experts, Harvard professor Avi Loeb. Professor, welcome back. Starting with these new images from ASA's ExoMars orbiter, what stands out to you? According to the European Space Agency, mission scientists weren't sure how well these images would turn out with a dim target so far away. Normally, these instruments are used to image objects more than 1,000 miles below. The color and stereo surface imaging system CASAs on EXOMs wasn't designed for this kind of imaging. For months, astronomers had been waiting for this encounter, hoping the world's fleet of Martian orbiters would glimpse the visitor as it crossed interplanetary space. When the day came, the object passed within about 30 million kilometers of the red planet. Close enough for cameras aboard ExoMars TGO, Mars Express, Tian-1, Hope, and NASA's Mars Reconnaissance Orbiter to try to capture it. Then, for a while, there was silence. Data releases stalled. NASA's operations slowed under a U.S. government shutdown, and the absence of images spawned the familiar online speculation that sometimes flares when science moves slower than imagination. Astrophysicist Avi Loeb, known for his outspoken commentaries on interstellar phenomena, stepped in to clarify the situation. The lack of immediate data, he explained, was no sign of conspiracy, but a symptom of ordinary bureaucracy. Long delays, he wrote, are not a signature of extraterrestrial alien intelligence, but rather of terrestrial human stupidity. Large research teams require time to process and verify data before release. And with many U.S. agencies partially shut down, the normal cadence of scientific communication had simply slowed to a crawl. In his view, patience, not paranoia, was the appropriate response. When the first confirmed images finally arrived, they came from the European Space Ice ExoMars Trace Gas Orbiter, TGO. Its color and stereo surface imaging system CASAs captured a small diffuse sphere of light extended modestly toward the sun. An echo of what the Hubble Space Telescope had seen months earlier when 3 Atlas was 10 times farther away. Then Hubble's camera had revealed a faint 4,000 kilometers wide glow slightly elongated in the direction of sunlight. Now near Mars, the same structure was visible. Smaller, sharper, but unmistakably familiar. The differences were technical, not physical. The TJO's mirror, only 5 centimeters across, gathers 300 times less light than Hubble's 2.4 mirror. Its angular resolution, about 2.3 arcsec pixel, translates to roughly 340 kilometers at the object's distance. Even the largest estimate for 3I Atlas's nucleus, around 46 kilometers, was far smaller than a single pixel. The spacecraft could not resolve the solid body at all, only the halo of dust and gas illuminated by the sun. Brightness data from NASA's Spree Observatory had already suggested a wide range of possible nucleus sizes. If the surface was bright and icy, the object might span tens of kilometers. If dark and carbon-rich, perhaps only a few. Even a 5 kilometers nucleus would contain some 33 billion tons of material, enough mass to keep its trajectory stable and prevent detectable deviations from outgassing forces. The absence of measurable non-gravitational acceleration implied that material was escaping slowly and symmetrically without giving the body a noticeable push. The CASAS images reinforce this interpretation. The brightest region around 3EI Atlas measured about twice the width of background stars, roughly 680 kilometers across. That was an order of magnitude smaller than the halo seen by Hubble. But the difference made sense. The smaller telescope aboard TGO could capture only the dense inner region of the glow, not the fainter outskirts visible to Hubble. When the brightness was corrected for the stronger sunlight near Mars, the two data sets lined up neatly, showing that the comet's outgassing had remained steady over the preceding 3 months. Other spacecraft joined in. The Mars Express orbiter used its Omega and SpyCam spectrometers. China's Tian-1 and the UAE's Hope mission also aimed. 3I Atlas was behaving like a familiar comet, but moving at interstellar speeds of over 30 kilometers per second relative to the Sun. By late 2025, astronomers had assembled a coherent picture, an active interstellar comet with a nucleus probably between 10 and 40 kilometers across, steady outgassing, and a remarkably flat orbit. The combined data from orbiters around Mars and telescopes on Earth provided the first interplanetary view of an extrasolar visitor, a milestone in collaborative space science. The implications reach far beyond a single comet. Interstellar objects like 3 Atlas are natural probes of the exchange of matter between planetary systems. Each carries isotopic fingerprints of the environment where it formed, its temperature, metallicity, and exposure to radiation. By comparing those signatures to solar system comets, scientists can test whether the processes that build planets are universal or vary across the galaxy. Matching chemistry would imply shared origins. Stark differences could point to alien conditions in distant star systems. Spectroscopic data from Mars Express and ExoMars are expected to sharpen that view. Instruments such as Omega, SPIAM, NOMAD, and ISIM were designed to detect faint emission lines from carbon dioxide, methane, and water vapor. Even partial detections could yield the first direct chemical comparison between an interstellar object and solar system material. Meanwhile, NASA's MAVEN spacecraft used its ultraviolet spectroscopy to look for volatiles invisible in optical light, adding another layer to the investigation. The study of 3 Atlas has become a case study in scientific restraint, a reminder that skepticism and curiosity must move hand in hand. The object's peculiar alignment and remarkably steady activity invite explanation, not speculation. It is in moments like these, when mystery and data coexist in uneasy balance, that science proves its true discipline. Rather than rushing to sensational conclusions, astronomers across the world have chosen patience, waiting for calibration files for confirmation from multiple instruments for the slow accumulation of evidence that transforms wonder into understanding. This discipline is not the absence of imagination, but its tempering. Each new image of 3I Atlas forced researchers to test competing hypotheses. Was its near-perfect ecliptic alignment a coincidence or a clue to some larger galactic pattern? Did its modest but consistent outgassing reveal an ordinary comet or a fragment forged in an environment unlike any in our solar system? Every question was allowed to mature through observation rather than impulse. The object's very ordinariness in some respects. Its gentle glow, its chemically familiar gases became as fascinating as its anomalies. In its quiet consistency, 3I Atlas taught a broader lesson that the universe often hides its most profound truths behind patterns that appear deceptively simple. Now, as 3I Atlas recedes into the darkness beyond Mars, it continues its escape from the sun's gravity at more than 30 kilometers per second, bound for the deep void between the stars. It will never return. Yet in its wake, it leaves a legacy of data, spectra, images, and trajectories that will be studied for decades. Each pixel and photon gathered during its brief passage through our neighborhood adds another layer to humanity's understanding of how material from distant systems drift through the galaxy. These fragments of light are in essence cosmic fingerprints, records of temperatures, compositions, and histories that no other probe could deliver. In them lies the story of the Milky Way's invisible commerce, the slow, steady trade of matter between worlds. The event marked a historic first. For the first time, orbiters around another planet played a direct role in observing an interstellar object. Mars, once merely a distant target of exploration, briefly became a scientific outpost for galactic research, a new node in humanity's expanding network of observation points across the solar system. The red planet's orbit